Hi, my name is Olamide Omolola, and I will be talking about our paper measurement and analysis of automated certificate reissuance in uh, the TLS ecosystem. This work was done in conjunction with colleagues from Maryland, Virginia Tech, and Northeastern University. So the TLS PKI is an essential component of the modern internet. It encrypts communication between users, but management is often not compliant with recommended security practices. Some of these non-recommended practices include compromised certificates are not revoked or properly reissued. Private keys are shared between stakeholders, usually between CDNs and users in the ecosystem. Now, since 2014, new changes have begun in the ecosystem. TLS sets are now free with the creation of CAs like Let's Encrypt. And free CAs issue free certificates which have shorter lifetimes. And these shorter lifetimes encourage the automation of set reissuance and installation. Open source protocols were created, such as Acme, to serve this purpose, and also tools were built on these protocols to allow administrators to automate the entire process easily. In this work, we focus on two main research questions. We examine if administrators are making proper use of automation, and do administrators use automated CAs react to large-scale compromises more responsibly. Our data set, we used the certificates we found from 2014 until 2020 from the Google City logs. We found about 5.3 billion. Out of that, we found 1.03 billion issued by Let's Encrypt, and about 188 million group certificates were found. So how do we identify reissuance? Reissuance, since we don't have access to the Let's Encrypt logs, we link certificates based on their subject alternate names. So we refer to this set of domains in the SAN list as the domain set, and certificates that have the same domain set are seen as either predecessor or successor of one another. And how do we know if a certificate replaced the new one? We use the login timestamp on the City log server as a proxy. So the first question is, are administrators making proper use of automation that modern CAs provide for certificate reissuance? We find that when plotting the median reissuance per domain set to the CDF, we found that over 60% of domain sets have a median reissuance time of 60 days. This aligns nicely with Setport, which reissues certificates after 60 days by default. Setport is one of the most popular Acme clients currently. How do we detect automation? The median reissuance time is not definitive because it focuses at a point in time, not the lifetime of all the median reissuance, the longitudinal view. So we check for automation by looking at reissuance period similarities, and to do this, we use the COV. COV is simply the standard deviation over its mean, and automated processes would have highly consistent, that is low COV, while non-automated would be very variable, would be highly variable, and they would have higher COV. And we find that the distribution of domain sets, out of all the domain sets, 30.3% of them have a COV less than 0.1. So does our automation hypothesis on automation hold? We examine how well our methodology matches, and we divide all domain sets by their COV and plot the CDF of all their median reissuance time. We find that COVs less than 0.01 are highly consistent. They reissue almost every 60 days. But COVs greater than 0.1 actually have a variable reissuance period. So we also take into consideration the fact that there could be an initial trial and error during the setup of Acme clients. And so we check for domain sets with at least 5 reissues, and we find that 48.2% of them have a COV less than 0.1. And if we ignore the first set of reissues and we find an additional 29.9%, we find that, if we ignore the first set of reissues and just check that there's at least 5 reissues remaining with a low COV, we find that the total jumps to 78%. Now, the next question is, how do administrators that use the automated CAs react to large-scale compromises responsibly? we used the natural experiment of the mis-issuance bug announced by Let's Encrypt in February 2020. Essentially, Let's Encrypt issued multi-domain certs, which it has checked the DCV, the domain control validation, in the past 30 days, but didn't recheck the CA records of the domain names within 8 hours of reissuing the certificate, of issuing the certificate. Instead, it only checked the CA record for one domain name n times. And so how do we infer reissuance? We look at the past 5 reissues before the bug date. And if the past 5 reissues were consistent, that means they have a low COV, and the next reissue after the bug date was high, that shows manual reissuance. That means it was reissued out of cycle. And if it's low, that means it continued on its regular schedule. In total, we found about 90,000 domain sets with a previous regular reissuance cycle. And out of this, we find that 33,000 of them at least saw a COV increase. This would form the basis of our next calculation or graph. We find out that when plotting the fraction of surviving certs, we found out that certificates that were manually reissued are actually reissued quite quickly, about 84% of them during a week. This could also be because Let's Encrypt threatened to revoke certificates en masse. However, this also shows a different behavior amongst administrators. In conclusion, we find out that most clients with a sufficient reissuance history have set up automated reissuance. Prompt manual reissuance occurred when required, and small changes could lead to significant management improvement like automation. Thank you.